Welcome to another GCSE Maths revision video from Griffin Maths. Today we're going to look at histograms. If you'd like the worksheet that accompanies this video, if you contact me at Griffin Maths, I'll get it sent over to you. Let's start by looking at the key things about a histogram. First thing you should notice is that the class widths in this grouped frequency table are different. 0 to 2, 2 to 4, then it goes 4 to 8, 8 to 16, and 16 to 20. So in this case, a histogram is important because we can't draw a bar chart, because it's the area of each of the bars that's important and not the height. So here we can see, when constructing histograms, the area of each bar is what is important. And the vertical axis becomes frequency density. This is calculated by doing the frequency divided by the class width. Let's have a look at our first problem here. So in this problem, we're given information about the speeds in kilometers an hour of 100 cars. So we've got the frequency table here, and then the axes to draw the histogram at the bottom. Notice there's no label on the vertical axis. This one's going to be frequency density. And to calculate frequency density, we do the frequency divided by the class width. The first thing we need to calculate is the class widths. I always write those here. Don't get this mixed up with the midpoint, which we'd use to estimate the mean. This is the width of the class. So 65 take away 60 is 5. That one is 5. That one is 10. And that one is 20. So we need a frequency density column here. 15 divided by 5. Make sure to divide them the right way. The frequency divided by the class width. It's 3. 25 divided by 5 is 5. 36 divided by 10, 3.6. 24 divided by 20 is 1.2. Bit of advice here is that you could use these in fractions to help you with the division if it's a non-calculator paper. What you then need to do is to decide yourself on the axes to use, the numbers on the vertical axes. So, because this will take some time, I've pre-prepared this answer here. So I've decided that 5 little squares are worth 1 on the frequency density axis, and the horizontal axis is already done for me. But notice that the bars have got different widths, and it's the area that's important. So this bar here happens to be the tallest, but it's worth 25, whereas this bar here isn't as tall, but it's wider, and that's worth 36. Here's a very similar problem on histograms. So again, we need to calculate the frequency density. So that's the frequency divided by the class width to construct the histogram. Frequency density goes on this axis, and it's the height that goes on that axis. Notice you need to determine this one yourself as well. So we need the class widths. 2, 2, 4, 8, and 4 again. Now we need to do the frequency density. Remember, you may be able to use a calculator if you need it. 7 divided by 2, 3.5. 14 divided by 2 is 7, and so on. Here is the completed histogram. Again, notice I've had to determine the numbers on the two axes myself. Here's a question for you to think about. Press pause and press play when you're ready for the answer. Right, let's have a look how we did this question here. Notice on this one we got part of the histogram and we got part of the frequency table. First thing I did is I coped with what I already knew. So I knew this one had a class width of 10, and I knew the frequency was 160. So So I calculated that frequency density was 16. And I popped that here on the vertical axis, which created it going up in 4s. On this question here, I could read off the frequency density was 4. I knew the class width was 15. So to find the frequency, I did the inverse operation, 15 times 4 to get 60. And then I worked through filling in the histogram until it was complete. Hopefully that's an in-depth look at histograms. If you've got any questions, get over to @GriffinMaths for more help. Bye for now.